Okay, so today we're just going to look at some practical questions, or more like, so getting into it. So these are actually taken from the Year 12 exam, because you do in Year 11 learn the basics and enough to be able to answer it. So let's have a look at this. So a manufacturer sells 3 products, A, B and C, through an outlet at 2 shopping centres, East Town and Knoxland. The number of units of each product sold per month is given in matrix Q, so you can see that. So let's have a look. The first question is asking us, what is write down the order of Q. So yeah, so it's got 2 rows and 3 columns, so it's a 2 by 3. Okay, then it says matrix P, shown below, gives the selling price of each of the products. So A costs $14.50, B costs $21.60, and C costs $19.20. So what they're asking us to do is evaluate. They want you to evaluate matrix M. So they're calling M is when equals QP. So you're going to times. You're going to have matrix Q and you're going to times it by matrix P. Okay? Because they just say evaluate, in this instant, you could just do it on your calculator, like type it in. But I am going to do one part of it manually, and then we'll pause and do it on our calculator, just because that's very important. Just because in this question they don't ask it, they could ask it in another instant. So I'm just going to write out Q here, because that's the first one. And you would then be timesing that by P, which was this one like that. Okay? So we're going to go over and we're going to practice what we've learnt so far. All right, so if underneath I put the order of Q, which you told me was 2, 3, what's the order of P?
3, 1.
Yeah, good. 3 by 1. So when they're calling our answer M, okay? So it's going to be M up here. So what will my answer look like? What type of order will it be?
2 by 1.
Good, awesome. It's going to be a 2 by 1. So let's like draw out a option there, like that. So a 2 by 1 means that you're going to have, 2 rows and 1 column. So there'd be 2 little answers there. So I'm sort of drawing it there. So what I'm going to show you is we're going to practice if we were manually doing this. So if we look here, this little cell is row 1, column 1. So I'm going to use row 1 with column 1. So what would happen there is 2,500 would get multiplied with 1450. Then you would add 3,400 being multiplied with 2160. Plus 1890 being multiplied with 1920. Sorry, ran out of a bit of room there. Okay, so that's how it would calculate that. That's how you would manually do it, and that's what the calculator's doing. So let's go I'm going to pause this video, and we're going to do this on our calculator. So let's just go and do that. All right, so we popped that into our calculator, and we got 145,978, and we got 171848.50. Okay, and we did see that our little calculation, if we did that separately, we did get the same number, so we knew we were doing it right. So these questions are the ones that then cause a little bit more challenging. It's because it says now, what does matrix M provide? So this one here, this is matrix M, what we just worked out here. Okay, so what I want you to do is go back to when you were multiplying, and you said that you took, matrix M became a 2 by 1. So what you did is you took the rows of Q and you took the columns of P, and that's what became this 2 by 1 here. So what that means is M has whatever the rows were in Q. So if I look up here, Q had, it was the shopping towns were the rows. So we will just pop them next to the rows here. So now I know that top number is something to do with East Town, and N is something to do with Knoxland. Now we took the columns of P. Now if you look at P's column was actually telling you a money price, wasn't it? So if I call that, so here I'm going to put money there. So now can you tell me, what do you think M tells me? Now that I've put that little pieces of information, what do you think M is telling me? Yep, Marcus?
The price of E and F.
Yeah, so the price of what? Yep.
Is it the money that's been made at each outlet?
Yeah, so the money made at each outlet or the total sales for that shopping town. Does that make sense? Yeah? And that's what we did. We could see we were multiplying every product that they had and they sold by the price, and then we added it together. So we were getting the total information. So what you're going to say is here, we have to be careful. So what information? So we'll say the total sales, or you can say, total sales made by each shopping centre. And we might, just so that we know, to give an example, so I'm going to say M11 equals East Town's total sales of, and then we'll just write how much it was. So I wrote M11 because it means row 1, column 1 of matrix M. Does that make sense? Yes? All right. Now, when it's the next question here, we've got to be really careful. It's easy to get these marks. So they're saying, explain why PQ is not defined. Now, if you look at P, you told me that was a 3 by 1 and Q was a 2 by 3. All right. So you know that these are not equal, so it's not defined. Now, you can't write that. That's just us working it out. What you actually have to write, and I'll write it in red, is you have to write what you just said there. So why is it not defined? Because the columns in the first one, which is P, so the columns in P, or I should say the number of columns, sorry. Number of columns in P does not equal the number of rows in Q. Okay? You have to write it out in words. Okay, there are 2 rides called the Big Dipper and the Terror Train at a carnival. The cost in dollars for a child to ride each ride is shown in the table below. So 6 children ride once only on the Big Dipper and once only on the Terror Train. Now, the total cost of the rides in dollars for these 6 children can be determined by the following calculation. So here, they want a total cost for the rides in dollars. So if you just want one total cost, what type of matrix would that be?
1 by 1.
Yeah, good. So you want a 1 by 1 because you want a 1 value answer. Yeah? Because it's the total cost.
Well, with that, you can already figure it out.
So knowing that it's a 1 by 1, we could go down and check, first of all, are these calculations defined? Because if they're not, you can't use that. And which one's going to give a 1 by 1? So if you look at this first one, this is a 1 by 1 by a 1 by 2. So is that one defined?
Yeah.
But what would the answer be? A 1 by 2. So that one's no good. I don't want that, and that's not the answer I want. Now, if I look at this next one, I've got a 1 by 1 with a 2 by 1. Is that defined? Is this one defined? No. So you can't even be done, so we'll get rid of that one. The next one is a 1 by 2 with a 1 by 2. Is that defined? No, that one's not defined, so we'll get rid of that one. And then what about this one? This is a 1 by 2 with a 2 by 1. Is this one defined? Yes. And what will it give my answer? A 1 by 1. Good. So let's have a look. If we multiplied these, we'd end up with this 1 by 1. So let's see how we would calculate that. It would be 6 times 7 plus 6 times 8. And that makes sense. That's what we want to do, isn't it? 6 kids rode the Big Dipper for $7. So you do 6 times 7 plus their 6 times they rode the other one, 6 times 8. Okay, so yep, this one ends up being our answer. Now you would move on once you get your answer. And if you have time at the end of the exam, come back and check the one that you haven't done. Does that one make sense? It is defined, but it's not good. Why is it not good? It's going to be a 2 by 2, and we want just one answer. Okay, so with this matrix powers, when you raise a matrix to a power, so say for example, I had this matrix here. I'm just making it up. So if I raise this matrix to a power, so it means I could square it. So I put the little number up there. What it simply means is that you're going to multiply that matrix by itself, okay? So the thing with matrix powers is the matrix must be square. So you can only have, and that's an important point to write, you can only square matrix or matrices can be raised to a power. So what do I mean? What do I mean by a square matrix?
2 by 2.
Yeah, 2 by 2 or 3 by 3. So the same amount of rows and columns. So, and you simply, and then the other thing is you need to write, we always do them on our calculator. Okay, so you don't have to ever do like the powers, like we don't manually make you do it all out, okay? So you just raise that, you just put that matrix in the calculator and you raise it to a power. So just for an example, if you see like, say we wanted to raise that matrix to the power of 3, just remember on your calculator, you use that little arrow button, which is next to the x squared button, and then you could do power of 3, okay? So if you have to do that, that's how you do it. So down here in this example, when they ask you to calculate, so they told me what A is and they told me what B is. So into our calculator, what you're going to type up is type in the A matrix and you're going to raise it to the power. Then you're going to press times and then you'll type in the B matrix. And you can do it all in one go. So all in one line. So I'm going to pause the video and let's do that and get our answer. Okay, so we got an answer of negative 2, 3, 16, 70, 174, 21, and negative 135. With this one, the identity matrix, an identity matrix is is always a square matrix, and it has ones on the leading diagonal and zeros elsewhere. So you can see here we've got ones on the leading diagonal. So the leading diagonal starts up in the left hand corner, so it starts here and always finishes down here. Okay, so you can only get a diagonal if you had a square matrix. So an identity matrix just has ones there and zeros everywhere else. If you times something, so you can see here, we've got the identity matrix written there, an identity matrix, a 2 by 2, and it gets multiplied with this other matrix which they're calling A. So an identity matrix is like a number 1. So if you times anything by it, you'll end up with the same answer. So down here in the example, it says find A times I. So if I wrote out A, sorry, I'll do it a bit bigger. If I wrote out A here and I times it by the identity matrix, which I can see because it has ones on the leading diagonal, I'm going to end up with the same thing. And you can test this on your calculator if you like. So this would be our answer. Now, it doesn't matter. This one, on identity matrix, the order won't make a difference. So even if I put the identity at the start, if I put it at the start, it will still produce that A matrix or the same one. Okay? So that's the only time the order doesn't make a difference, is with the identity matrix. So I can have an identity matrix. So don't be, if I asked you to create a 3x3 identity matrix, you will have like 1, 1, 1, and then you'll have your zeros elsewhere. Yeah? So that would be a 3x3 identity matrix. So if they ask you to create one, that's what you're going to do. Okay, so with this one, it says find the values of the pronumerals. So that just means the letters. Okay, so if you look down here, we have A, B, C, and D. Okay, so we've got to find the letters. Now, when we have adding matrices, you know you have to they have to be the same order, which they are, and then we add them together. So if you look at it, but first we had a scalar number out the front. So if I multiplied that bit out first, so remember a scalar means you multiply every number in there by the number outside. So I would have that, and then I'll do this for the 2 as well. So it'd be 2b plus 6 plus negative 2 plus 14. Okay. So, and then what they're saying is they're saying it equals this. Okay, so what you know, when you add matrices, you go this number plus that number would equal that spot, wouldn't it? So essentially what you are creating is you're creating an equation, yeah? And then you've got to solve it. Now, in general maths, don't stress too much. We don't really test your algebraic skills on solving. You don't really need to have to be able to do that because we can use our solve function on our calculator. But that's how you could create an equation for it. So what about if I did, just to show you the other one, 3a plus 6, this could be another one. And what would that equal? 3, good. And then you've got the other ones. We can probably find out what C is because we know negative 6 plus negative 2 equals C. So what does C actually equal? Negative 8? Yeah, you could already see that one. And what would D equal?
32.
You add those two together, wouldn't it? It'd be 18 plus 14 equals D. So we've got 32 equals D. So those two, now that we've got C and D, but we still need to find these two. And these two are in equations. So what we can do on our calculator is we can do the solve function. And then you type the equation that you've got. And you just go comma B. Okay? And then what you'll get is you'll get that B equals 2. Okay, so just so you know, how do we get this on our calculator? Menu 3, 1 is often how kids remember it quickly. So then we'd have to do the other one that we don't know, solve, which was 3a plus 6 equals 3, comma A, and you'll end up with A equals negative 1. Okay, so now you've found your 3 letters.